Hi friends, welcome to my channel. Let us discuss how to do the projections of a given hexagonal pyramid. The given question is a hexagonal pyramid of base side 30 mm and axis 60 mm has one of its slant edges on the HV. HV means horizontal plane and inclined at 45 degrees to VP. VP here vertical plane. Full stop. Draw its projections when the base is visible. Here they have given hexagonal pyramid. I did the rough diagram here. Hexagonal pyramid means the name indicates it has one hexagon. Okay, it is called base. All sides of the hexagon has equal length. And then pyramid means this hexagon is connected to the apex with the slant edges. Okay, and this point is called apex. AO is one slant edge, BO is another slant edge, CO is another slant edge, like that. How many slant edges will be there? At each corner one slant edge. So 6 corners are there, 6 slant edges will be there. Okay, and here if you are taking this surface ABO, okay, it is a triangular face, it is looking like triangle. Okay, and similarly BCO, it is also another triangle. CDO, it is also another triangular face, we are calling it is a triangular face. So this apex and this hexagon is connected with the help of triangular faces. Okay, and here we are taking one line which is joining apex to the center of this hexagon. Assume O1 is the center of this hexagon. If we join apex to center, it is one imaginary line is coming, it is called axis. Always we are showing axis with two big lines with a dot. Okay, so this imaginary line distance from O to O1, it is called height of the pyramid. Okay, we are taking small h. So in it, first take the given data. Base side is 30 mm. So each side of the hexagon is 3 centimeter. And then axis is 60 mm. That is height of the pyramid is 60 mm, 6 centimeters. And then some conditions are given here. So according to those conditions, we have to do the projections. So instead of conditions, I have written stage 1, stage 2, stage 3. In 3 stages, we will do the diagram. Okay, we will do the projections. What are the projections? Projections means front view of the given pyramid and top view of the given pyramid. Okay, for keeping this pyramid, we are taking the first quadrant. As we know, first quadrant means this area between vertical plane and horizontal plane is called first quadrant. And this is second, third, fourth. According to our syllabus, we have to keep the solid in the first quadrant. Okay, and the angle between horizontal plane and vertical plane is 90 degrees. In the shortcut form, we are writing vertical plane means VP, horizontal plane means HP. Okay, this is a 2D view. We are keeping this solid here in this portion. We have to do the front view and top view of that object. Okay, and in 3D view, if you are taking 3D, this vertical plane is looking like this. Okay, this is VP and this horizontal plane is looking like this. This is HP and the angle between these two is 90 and the line joining both planes is called XY line or reference line. Okay, so here we have to keep the solid. For keeping the solid, in the question some conditions are given. According to those conditions, we have to do the projections. Projections means, as I told, it is a front view of the object and top view of the object. Okay, take the first condition. Okay, so here in the first stage I did the assumption. In the second and third, whatever data is given, I have written. Okay, I took the second condition. Here one of its slant edges on the HP. So I have written the same thing in stage 2. One of the slant edge on the HP. Okay. And then what is a slant edge? If you are taking this pyramid, it is a slant edge. This slant edge is on the horizontal plane. So I am keeping, let us assume this is the horizontal plane. This slant edge, let us assume OD. OD is the slant edge. This is O, this is T. I am keeping this on the horizontal plane like this. Okay. This is the condition they have given. One of the slant edge on the HP. And next condition they have given, and inclined at 45 degrees to VP. So same thing I have written, inclined at 45 degrees to VP. which is inclined to 45 degrees to VP means the same thing, whatever slant edge is there, that slant edge is inclined at 45 degrees to VP. So here the slant edge is on the HP like this, again it is tilting like this, okay, with the vertical plane 45 degrees. So here if it is in this way, we can't do the front view and top view. What we are assuming, it is like this initially, okay. After that, this edge, in the first stage I am assuming like this, in the second stage I am taking this condition, one of the slant edge on the HP like this I am taking. I am tilting the entire pyramid in this direction like this, okay. So first assumption is, our first assumption, whatever axis is there, okay, this is the axis, it is perpendicular to the horizontal plane. We are keeping the pyramid like this, okay. So in this position we have to do the front view and top view of the object, okay. So I took here stage 1 assumption, I am taking axis is perpendicular to HP. In next stage what I am taking, this slant edge is tilting or on the HP, on the ground, okay. After that, after these two stages I will do the third stage. Now here take this pyramid as it is on the plane, horizontal plane. Now just do this diagram like this. We are keeping this solid here. This is the center, this is the height, okay, perpendicular to the horizontal plane, and this is the apex. These are the slant edges like this, okay. We have to take the projections of this solid. Projections means, as I told, front view of the object we have to see from this side, front view in the shortcut form FV I am taking, and top view of that object from this direction we have to see, it is called top view, TV we are writing, okay. These are the projections of the first stage, so that is assumption. Now here in the front view we can see the pyramid height in the triangular shape on the vertical plane, okay. If we take top view, the image of top view is coming like hexagon, it is looking like hexagon on the horizontal plane, okay. So we need to do the both front view and top view of this pyramid. I am roughly doing, let us give this edge, OD edge is important for us, okay. This edge is here only, it is again in the next stage it is on the HP, okay. So first do the front view of this, front view and top view. Wherever polygon is coming, do that view. In the top view we can see the polygon, okay, and this gap is not given, how much distance from vertical plane, that's why take any gap and do the top view, okay. We can see the hexagon on the horizontal plane in top view. So again we are tilting this horizontal plane in downward direction, it is coming like this, so we can see the hexagon in the top view like this, got it. We can see the center and we can see the slant edges also in the top view, so those are all meeting, it is looking like all are meeting at the center. And in the front view we can see this triangular shape. For getting front view we have to do the projector lines, and we have to take the axis, we have to do the slant edges like this, okay. Roughly I did here. So this is the front view, this is the top view. So here right in the vertical plane we can see front view, in the horizontal plane we can see top view. So this is the first stage. Let us do the first stage, after that we will take the second stage, okay. Do in the sheet, draw all diagrams with pencil. Here for getting clear view I am using pen. First do the XY line of any length. So I did XY line of some length. After that take some gap, do the hexagon here. For doing the hexagon, first I will take the side length, that is 3 cm, okay. After that we are using the outer angle formula for doing the hexagon. I will do the hexagon like this. Take this angle is outer angle. We have one formula for doing this hexagon. So that formula is 360 by 6 sides it has, okay, for hexagon. So take whatever number of sides are there for the polygon, take that number. For hexagon take 6, it is 60 degrees, okay. So outer angle at all the corners is same, it is 60. This is 60, okay, and if you are taking this is also 60, Okay, and this side is also 60. Okay, if you are taking like this angle is also 60 degrees. First do the hexagon. Here I did the XY line of some length. After some gap, do the hexagon. Hexagon, here I am taking 3 centimeter line initially. So after getting 3, take this angle, it is 60 degrees, and do this line. Now in this direction do 3 centimeter line. Similarly this side also take 60 degrees, this side, and do 3 centimeter line. Now after that, here also if you are taking here, this is also outer angle, take 60 degrees here for this line, 60 here. So in this direction take 3 centimeter line. Similarly here also take 60 degrees line. Now take the line in this direction 3 centimeter. Check this side is 3 centimeter or not. Now it is perfectly 3 centimeter. Just do one line here of 3. Now give the corner names for this. Here we are giving in the top view small letters A, B, C, D, E, F. This is the top view. Okay. In the top view we can see the polygon as well as these slant edges. Here all slant edges are meeting at the center of the polygon. Okay. So at each corner one line, all are meeting at the center. Okay. Here if we join opposite ends, this intersection point is the center. Okay, and these are the slant edges, all are meeting at the center. Here also do slant edges, here also do the slant edges. Okay, all are meeting at the center. For center we are giving O1. Okay, and then in the top view we can see this apex also at the center of this polygon. Apex we are giving O, so we can see this O from the top at the center of the polygon. So I am giving both O and O1 at the same point. Okay, these are the slant edges from the top. So do the projectile lines at all the points. As we know, projectile lines are 90 degrees to the XY line. Okay, so just for keeping this 90 degrees, I am taking this XY line is a reference line. Just do one projectile line here. Okay, and similarly do here also one projectile line. This is the reference. For getting 90 degrees I am using this. So here projectile line is passing through 2 points, and then here at the D point. And similarly this side also, this scale should coincide with XY. Now here give the intersection point. In the top view we are giving small letters A, B, C, D like that. In the front view we are giving A dash. Here B dash, F dash are coming at the same point. B dash, F dash. Here base is coming. Base we are giving O1 dash. O1 name we are giving for base. Top view, in the front view it is O1 dash. Here C dash, E dash. Here D dash. After that in the front view as I told. So let us do the front view of this. If you see from this side we can see the entire height of the pyramid on the vertical plane. Okay, and then after that we can see the slant edges also. So here what is the height? It is 6 centimeters. We can see this entire height from the XY line. Okay, first take the axis line of height 6 centimeters above XY. For doing the front view, first do the axis line of 6 centimeters above XY. So this is 6 centimeters from XY. Mark the apex. Apex we are giving O. Do the axis line here between O and this base. Axis line is 2 big lines with a dot. Like this. Now we can see the slant edges also. Okay, in the front view. Join A dash to apex. This is one slant edge and this is another slant edge. Okay, this is the front view and this is the top view. Now in next case, in stage 2, one of its slant edge on the HP. Okay, let us take this OD is one of the slant edge, this slant edge. This is O, this is T. It is on the horizontal plane. Okay, initially we took like this. In next case, it is tilting like this. Okay, it is on the horizontal plane. This edge is on the horizontal plane like this. Okay, so whatever front view is coming, the entire front view is tilting like this. Okay, let us do the second stage. Now this OD is coming on the XY line. Okay, the entire triangle is tilting here. Now I am marking D point is after some gap. Here D dash I am marking this D dash. Now after that, take this length. It is on XY line. Okay, by using compass, D dash as center, take this length. Okay, so mark that length here. So this edge is coming here. Okay, now take this point is O dash here. Now we have marked this edge on the ground. Now do the remaining parts also. Mark A dash. How to mark A dash? We know this length by using compass. So D dash as center, just do an arc here. Okay, from O dash take this length. Now from O dash cut this arc. We will get this point, A dash point. Join D dash A dash with the help of scale. And then join A dash O dash. Now mark these points also on the A dash D dash. Okay, so from D dash take this length. Here mark the length. It is C dash C dash. So after this point, mark O dash. Mark this point O1 dash. Now take this length. This point is B dash F dash. After getting all the points on the base, join these points to apex, that is O dash. And this is the axis. Axis means two big lines with a dot. Same front view we are tilting like this so that this edge on the ground, OD edge. After that, for getting the top view, just do the projectile lines from all the points. This is the reference line. Okay, vertical line. Do the parallel lines. These are the projectile lines. Okay, do with light color. From these points also do the horizontal projectile line. Take XY line as a reference line. Now take the intersection points here. A horizontal line, A vertical line. This is small a. B horizontal line, B vertical line, take B point, intersection point. C horizontal line, C vertical line, take C point. And D horizontal line, D vertical line, this is a D point. E horizontal line, E vertical line, take this is E. And F horizontal line, F vertical line, F. And then center, O dash, O1 vertical line, O1 horizontal line, this is O1. Apex, O dash vertical line, O horizontal line, take this is the apex. Okay, here join all outer points with the continuous lines. Here what are the outer points? O, F, E, D, C, B and O. Okay. By using scale, join those outer points. So after joining all outer points, so A is the inner point. If you see from top, okay, forgetting the top view, so in this direction we have to see, we can see the entire face of the polygon. Okay, we can see A point also. So do here also continuous lines. A is joining with which points? A to B and A to F. Do the continuous line A to B and A to F and then A is joining to apex also. This is also continuous. From each point 3 lines are passing in the solid. Okay, from the top we can't see this slant edge. Okay, it is slant edge is CO and EO. So here C to O we can't see that edge, and E to O, those edges are hidden edges. So we have to take the dashed line. You have to join CO slant edge with dashed line. Dashed line indicates invisible edge, and then EO. After these two, from the top we can't see this edge also because it is on the ground. We can't see OD slant edge. So OD is dotted line. So here dotted line and this continuous line is coinciding. So whatever part we are seeing dotted line, do that one like this, and remaining here also dotted, but continuous line is covering it. It is called stage 2. In stage 2 the slant edge is on the horizontal plane. Let us take the stage 3. In the stage 3, whatever slant edge is on the HP, that is inclined at 45 degrees to VP. Okay, always remember angle with VP means we are getting the line below XY. Let us take this is the XY line. Angle with VP means we are getting the line like this. Okay, this angle is with VP. Okay, which is making angle with VP means whatever slant edge is on the HP, that edge is tilting VP. So here which edge is slant edge with OD. Okay, here on the 45 degrees line, this angle is 45 degrees with VP. On this line we have to take OD length. Okay, let us take this is O, this is D. Okay, this edge is tilting 45 degrees with VP. Let us do the diagram. Now take any one of the point. At this point take 45 degrees line. Just do one line of 45 degrees. Now mark this angle is 45 degrees. On it take this edge. Okay, OD edge. Take any one of the point is O here. Okay, mark this OD length on the axis. From O, mark on the 45 degrees. Take this is D point. Okay, why we are taking OD length here means whatever slant edge on the horizontal plane, the same slant edge is tilting 45 degrees. Okay, we are marking O and D. What are the other points on the same line? A and O1. Okay, take OA length. From O, mark A here. This is A. So here mark this length. Okay, from A. After getting all the points on this 45 degrees line, next mark C point. Okay, take DC length. So D as center, just do an arc here. Similarly take OC length also. Now O as center, cut this arc. So we have to take intersection point. So this intersection point is C here. Next mark B point. Take this length from D point. From D do an arc. Similarly from O also take this length. Cut this arc. This is B point. Mark next E point. D as center, do an arc. Similarly from O, take this length, OE length. From O, cut this arc. We will get E point. Similarly mark F. And OF. Here we have to take intersection. Take DF length again. From D, extend this arc. take the intersection point F. So here we got all the points. Okay, now join whatever continuous lines are there. Do the same thing here also. Join DC and DE. EF and then CB. Join AF, okay, and then join AB. So after that join OF, and then join OB, and then join OE with dotted line, and then join CO with dotted line. This is the top view. For getting the front view, do the projector lines from all the points. Take any one of the vertical line is the reference line. Do the vertical lines, vertical projector lines from all the points. And from these points also do the horizontal projector lines. Take this is the reference line. Already XL line is there. Here from C and E. Now take the intersection points. A horizontal line, A vertical line. Okay, take this is A dash. Similarly B horizontal line, B vertical line. Take this is B dash. C horizontal line, C vertical line. Take this is C dash. Similarly D vertical line, D horizontal line. Take this is D dash. E horizontal line, E vertical line. Take this is E dash. F horizontal line, F vertical line. Take this is F dash. Center vertical line, center horizontal line. Take this is O1 dash. And then next apex horizontal line, apex vertical line. Take this is O dash. Here for joining these points, if we see from this side, okay, we can see this view, correct? If we see from this side, we can see the entire polygon. Okay, so whatever polygon points are there, join with continuous lines because it is visible from this direction. Okay, so join all the A to F points with continuous lines. Join AB and then BC and then CD and then DE, EF, AF. Now this is a polygon we can see from this side. Okay, if you are taking the arrow here, we can see the entire polygon. And from this direction, we can see this edge also, O and B. Okay, here also O dash B dash is the continuous line because it is visible. So if you see from this side, we can see OB edge we did just now. We can see this edge also. Okay, from this direction we can see this edge also. So from C to D, so this C and D edges, slant edges we can see from this direction. So from C and D, do the continuous lines to the apex. And after that, from this direction, we can't see these edges which are passing through E and F. We can't see these slant edges. So from E and F, okay, join the apex with dotted line. Those are the invisible slant edges. And then from F and apex also, dotted line. This is the final front view and the final top view in stage 3. Okay, here stage 1 is the assumption. We are taking axis is perpendicular to the ground. In stage 2, this one of the slant edge, that is OD edge, is on the ground. In the stage 3, this OD edge is tilting 45 degrees with VP. So in these diagrams, mark the given dimension. Side length of the hexagon is 30 mm and the axis height is 50 mm. And here this angle is making 45 degrees with VP. These are the 3 main stages for doing the projections. Okay. In these projections, both front view and top view should be in dark color compared to the projector lines. Okay. The drawing sheet you do with pencil, all the front views and top views. Don't use pen. For just getting the clear view in the camera, I am using pen. And other video lectures of projections of solid, I will give the video link in description box. Please check it. If you like this lecture, please hit the like button and subscribe my channel and share with your friends. Thank you for watching.